Alright, so what we're going to be looking at now is we're going to be looking at something called implicit differentiation. And so what an implicit differentiation is something when you get an equation like this. So if you're asked to find the derivative of y to the fourth plus xy equals 3x, or x cubed minus x plus 2. As you see, what we've been dealing with mostly has been like f of x is equal to x squared plus 2x, only one variable. Or in the cases where we can get the y all by itself. We'll get like y equals 3x plus 2. And we're able to get the y by itself. But in this case, we can't get the y by itself, so just using our normal differentiation, we cannot use that. So what we have to do is we have to use something called implicit differentiation, which allows us to find the derivative of this. Implicit differentiation. I'm going to start with this problem. Now, this one is a lot easier. And you actually can solve for y in this case, but I'm just using this as a demonstration to keep it simple. So, what you're going to do is you're going to find the derivative of both sides. X squared plus y squared is equal to the derivative of 1. The derivative of 1 we all know is 0, and now you're going to take the derivative of each of these. Now the first one's going to be just 2x, and then you're going to multiply it by dx over dx. Well, what is dx over dx? It's 1. So all the ones that we've actually been doing have this at the end of it, but we just don't put it because it's 1. And now the next one would be 2y dy over dx is equal to 0. Okay. So as you see, now we have dy over dx. Well, when we're trying to solve these, that's what we're trying to get, is we're trying to get this all by itself. Our answers are always in dy over dx, or d whatever the one variable over the other variable is equal to. And so that's what we're trying to get by itself. So now we're just going to use algebra and go, okay, we're going to solve for dy over dx. So you subtract 2x on both sides, and then you divide by 2x. So you end with, you've got 2y dy over dx is equal to negative 2x. Divide by 2y, giving us dy over dx is equal to negative x over y. And now if we want to find the slope of this circle at any given point, all we have to do is plug in the x and y coordinates for that function at that point. Okay? Pretty cool. So now, if we ever have any functions that do have this, where we can't get the y by itself, we can now take we can find the deviation of it at a given point. There's all that. So here's the rest of it all the way through, and as you see, there it is. So here's a little summary of what it was before. Whenever we take the deviation of like x cubed, we just drop the power subtracted by 1, but then at the end we have this dx over dx. Well, dx over dx is 1, so that's why we just haven't been putting it. Now if you take it to a different variable, y, in terms of x, then we leave that variable up top with that d, so it'd be dy over dx. So in this case we got 3y squared times dy over dx. So if you had a function in, let's say you had d over dx and you had 3t squared. Okay. What you'll do is you'll drop the power, which will give you 6t, okay, just a normal deviation, but then you have dt over dx. Whatever that variable is that you're using in your function, that goes on top, and the one that you're taking it in terms of, which is usually x, that's going to be on the bottom. Okay. Implicit differentiation. So now let's look back at the one that we looked at previously in the very beginning. You're going to take the derivative of each and every one of these. So the first one, you're just going to drop the power. So it's going to be 4y cubed dy over dx. Okay. Now this side, we're going to work on the far side. It's just going to be 3x squared minus 1. Typical deviation, you guys all know that. So now we're going to look at the middle. Well, we've got a product rule here, x times y, which means we're going to take x times the derivative of y plus y times the derivative of x. Well, the derivative of y is 1 dy dx. So it's going to be x times dy over dx, okay, plus y times 1, because the derivative of x is always 1. Now that's being added to 4y cubed dy over dx, and that's equal to 3x squared minus 1. Now we're going to get the dy dx's all by themselves on one side, so we're going to move this y to the other side. Okay. So now we're going to take a dy dx out, leaving you with 4y cubed plus x is equal to 3x squared minus 1 minus y. Okay, so I've moved the y over, and then I took a dy dx out of both of those. And now you want to get the dy dx by itself, divide it through, giving you dy over dx is equal to 3x squared minus 1 minus y, all over 4y cubed plus x. Okay. And that would be our deviation or differentiation of this function for any point. Okay. So I got all this stuff coming up. Yada yada yada. So if this was our function and we wanted to find what is the curve at the point 1, 1, for the x's we're going to plug in a 1, and for the y's we're going to plug in a 1. Okay, so it would be 3 minus 1 minus 1 all over 4 plus 1. And this would be our dy dx at 1 comma 1. And that gets us a 1/5. And that would be our slope. So for this curve that we have, which looks really weird, it looks something like that. It's not a function, but it is still a graph. At the point 1, 1, that slope there is 1/5. Okay. All right. So implicit differentiation. All right, so now if we have this one, what we have here is that we're going to have to use the chain rule along with it. And so I'm going to work on the right-hand side to start, this side right here, because it's going to be quick and painless. Derivative of cosine x would be negative sine x. Okay. And the derivative of cosine y would be sine y dy dx. Ta-da! Look at that. And so we're done with that side. So it was negative. Negative times a negative is a positive, is why it's there. So now on this side, I'm going to take this x squared, or square root of 2, put it out front. That gives us the derivative of cosine. Okay, derivative of cosine is a negative sign, so I'm going to put a negative out front. So it'd be negative sine of x plus y. And now since we're using the chain rule, okay, this is going to be our u prime would be 1 plus dy over dx, okay, because we've got to take the derivative of both of these. So we're going to multiply this by 1 plus dy over dx. All right. Now what we're going to want to do is we're going to want to distribute this to both parts. That gets us a negative root 2 sine of x plus y minus root 2 sine x plus y times dy over dx, and that equals this whole thing. I'm going to want to move this to one side and move this to the other side. Okay. So I want to get the dy's and dx's on the same side, which I have sine y dy over dx plus the square root of 2 sine x plus y dy over dx is equal to, looks like it's going to be sine x minus root 2 sine x plus y. And now I'm going to get the dy dx's by themselves. Dy over dx sine y plus root 2 sine x plus y. And then I've got this whole thing, and then I'm going to divide it by there. And so my answer ends up being right there. And now if I want to find the derivative at this point, I plug pi over 4 into the y's and negative pi over 4 into the 2's, and you're just getting up a negative 1/3. So there is your implicit differentiation that you would be doing. So after you plug them all in, you can find those points. Okay. All right. So your IRAT. What your IRAT is? So what IRAT is your individual readiness assurance test. So what you're going to do here is that you're going to find you're going to do implicit differentiation on each of these in terms of x. So just like what we've done before with these. So the first one you want to find when dy over dx, the second one also dy over dx, and the third one you want to find dt over dx. Okay. So again, in terms of x. So you're going to be using your implicit differentiation to solve these, and then you're going to bring these in and we're going to check them in class, and then you're going to do more problems in class with this so you can test them out. So what basically is your homework is that you're going to be solving out these three problems using implicit differentiation. All right?